Hello Labmentix, this is Kaushik Dev, and today I'm going to present to you my second project. Uh, it's the project type is EDA regression, and the project name is Amazon Prime EDA and ML. The contribution was individual, and it is done by me, Kaushik Dev. So the project summary is that I've done EDA and ML on machine learning, applied EDA and exploratory data analysis, and machine learning on Amazon Prime TV show and movie dataset. The goal of this object was to first I've provided the summary of the EDA part, and then I've provided the summary of the ML part. So the goal of this project was to analyze and extract insights from a merged data set that combines movie and slash show metadata with cast and crew information. The analysis was focused on understanding trends in film production, identifying key factors and directors, and evaluating movie performance and metrics. So I would all of this is explained in the project itself or the rest of the part of the project summary. For the ML part, the goal of this project was to predict IMDb scores of movies using advanced machine learning models, including gradient boosting regression, and XGBoost regression, while optimizing performance through hyperparameter tuning and model explainability techniques. So again, the rest of the things are explained in the project itself. Here I have provided the GitHub link. Uh, so the problem statement is that the entertainment industry produces a vast amount of content across various genres, platforms, and formats and platforms. However, understanding key trends in film and television production, influence of cast and crew on a title success, and the factors that contribute to high ratings remains a challenge. So this project aims to perform exploratory data analysis and machine learning on a merged dataset containing movie show and metadata and classified details. The objective is to uncover insights related to the most common and influential actors, directors, and other cinematic roles, patterns in movie and show genres, run times, and production trends over time. The relationship between various factors such as genre, runtime, and cast and performance metrics like IMDb and TMDb rating. By analyzing these trends, these factors, the project will provide a data-driven understanding of entertainment industry, helping stakeholders such as production companies, casting directors, and streaming services make informed decisions. So yes, let's begin. I've imported the basic libraries. I will import many other libraries as required later on. So first I have loaded the two different data sets that were provided to us, which is credits and titles CSV. Then I merged these data sets using a left join on the ID column. Then I have displayed the first couple of first five rows of the data set, combined data set, merged data set. Then the shape of the data set is as such, 1,24,347 and 19. So rows and columns, 19 rows and columns. So this is the info. Some of them are objects, some of them are integers, some of them are float 64, float values, 64-bit float values. So the duplicate values, I've since we have to find out the count, we don't have to remove the duplicate values right now. This is what it is. 168. That's the count of the duplicate values. Then I've graphed out the machine missing values in the merged data sets in each column. So this is the missing values. So what do I know about my data set right now? So the total rows are 124,235 and 19 columns. The movie show information, ID, title type, release year, genres, runtime description, cast include details, name, character, role, performance metrics, IMDb score, uh, and performance metrics, IMDb score, IMDb votes, TMDB score, TMDB popularity. Data issues, which are duplicates and missing values, 168 duplicate rows and missing values such as character 16,307, 68 certification 67,640, numerous missing values in the dataset. So initial observations, we can graph out movies versus shows, genre distribution, popular act roles, and ratings and popularity. So the data contains both movies and TV shows. This titles belong to multiple genres stored in a list format. Actor and director are the most common roles. IMDb score, IMDb votes, IMDb score help evaluate performance. Understanding the variables, this is the info of the variables again. Dataset. This is the merged dataset. Describe. Now variables description, something we'll not look at. Check unique values for each variable. Unique values, we can see these are the count of the unique values in each variable. So now I've removed, in the data wrangling part, I've removed the duplicates. I've dropped the duplicates rows. Um, I've handled the missing values, and this is what it is. This is the result. These are just some suggestions. It's not an error. So what all manipulations I have done? I removed the 168 duplicate rows, reducing the dataset to 1024 124,179 rows. Handle the missing values, filled character with unknown for actors, replace missing description with no description available, set age certification as unrated for missing values, set seasons to 0 for movies, filled missing IMDb score and TMDB score with their median values, set missing IMDb scores and TMDB popularity to 0, converted genres and productions to list format for better analysis, standardized data types, release year, runtime, IMDb votes as integers. So I've already done standardization here, but I will do it again later. So this is the first. I'm going to describe 5 charts since there is a barrier of time. So I've done all 13 charts, but I'm going to describe only 5 charts. So the first is the distribution of movies versus shows. As we can see in this data set, there are more movies than shows. Uh, so the positive insight is that if the platform wants to invest in content focusing on movies, they cater to a larger audience. Under investment in TV shows could lead to lose long-time subscribers who reverse series over movies. The top 10 most common genres is the second chart, distribution of it. So this bar plot identifies, why did I pick this specific chart? Because this bar plot identifies preferences, audience preferences based on the most frequent genres. So drama, comedy, and action are the most uh, drama, comedy, action, and thriller are the most dominant genres. What are the insights that I gained? Positive insight is that streaming services can prioritize these genres for production and licensing details. Negative insight is that oversaturation of these genres could limit diversity, making niche audiences feel neglected, leading to a downtime of business. So this his plot is the distribution of movies and shows released over the years, trend analysis of the movies and shows released over the years. So there was why did I pick this specific chart? Because this his plot understands how content production has evolved over time. Histogram plot. Mm, what are the insights on the chart? A surge in releases during the 2010s, but a decline after 2020, probably due to the COVID-19 pandemic. You can see a surge from the 2010s and then a decline after 2020 because of the COVID-19 pandemic, probably. Identifies golden periods for content. Positive insight identifies golden periods for content creation and industry growth. Decline post 2020 could indicate a potential market saturation or impact of streaming service competition. So the fourth chart is that is the distribution of IMDb scores. It examines the why did I pick this specific chart? Because it examines the quality perception of the content. Most content has IMDb ratings between 5 and 8. That is the insight. Positive insight, a high engagement expected for well-rated content, driving better recommendations. Negative insight, a large volume of mid-rated contents could indicate a lack of exceptional titles that drive strong engagement. That is the problem with Amazon Prime. Negative. Uh, Mid-rated content is a lot, and there is a shortage of uh, high-rated content. So these are the rest of the charts. So I'm just going to go skip to the correlation heat map. So this is the correlation heat map. Why did I pick this specific chart? A correlation heat map represents relationships between numerical variables in the data set. It helps identify strongly correlated variables which can aid in feature selection for machine learning. Weak or negative correlations which can indicate independent factors, redundant variables that do not contribute new information. So IMDb score and TMDB score are strongly positive correlation. If a movie is highly rated on IMDb, it is also likely to have a high TMDB rating, which is the audience rating. So this is the pair plot again. So I've described 5 charts. Now let's come on to the hypothetical statement. So the first null hypothesis is that the average IMDb scores for movies and TV shows are the same. The alternative hypothesis for the first hypothesis is that the average IMDb score for movies and TV shows are different. So as we can see, the t statistics are non-infinite values fail to result in no significant. The result is that no significant uh, difference in IMDb scores. So independent t-test. Uh, it was to compare the means of two independent groups. So the second hypothetical statement, null hypothesis statement, is that there is no correlation between runtime and IMDb scores. Alternative hypothesis is that there is a positive correlation between runtime and IMDb scores. So I've done a Pearson correlation test. So this returns the value of 0.0981. Significant correlation, which shows that there is a significant alternative hypothesis is true. Significant correlation between runtime and IMDb score. So Pearson correlation test, what I have done to check, it was done to check linear relationship between two numerical variables. So the third null hypothesis statement, is that the mean score across all titles is less than or equal to 7.0. The alternative hypothesis is that mean IMDb score of all titles is greater than 10.0. So the result was that no significant evidence that the average score is above 7. Failed to reject the null hypothesis. So it is usually below 7 or equal to 7. So the null hypothesis is 2. One sample t-test I've done here for the statistical test, and it was done to check the mean of a sample significantly different from a given value. Now let's come on to the feature engineering and data processing part. Since I've applied ML models on in this data set. So again, I'm handling the missing values and the non-infinite, non-finite values. So I've checked it. I dropped rows where IMDb ID calling is missing and reset indexing index after dropping rows, verifying missing values are removed. So yes. So this is the description of what all I have done, which I've already described. Handing outliers, I've done this using the code that is written right here, using the IQR technique. So I visualize the outlier treatment. Yeah. Categorical encoding. So I've used a label encoder to do categorical encoding to change the categorical columns into integers. There's no textual data processing to be done on this data set since it's not a NLP data set or a sentiment analysis or a text clustering data set. So the feature manipulation I've done using a correlation heat map. So I've added some features such as engagement score and release age. We'll find out later that engagement score is the most important feature. So the feature selection, remove low variance features, drop highly correlated features, select all features using mutual information. So I've used mutual information to uh, improve the model performance and remove irrelevant and redundant features. Variance threshold I've also used to remove features with low variance. Correlation analysis, drop highly correlated features to reduce multicollinearity. So the target variable that I've chosen is IMDb score. So according to that, I've done the feature selection. So TMDB popularity and IMDb codes and TMDB scores are highly significant. So the data transformation, I've done log transformation and standardization and min-max scaling in the data transformation. Data scaling has already been done in the min data transformation section. I've done PCA, principal component analysis, to do dimensionality reduction using this code. So now I split the data set into an 80-20% uh, sample train and test data set. The training set has 94,636 samples and the test set has 23,660 samples. So the data set is highly imbalanced. IMDb scores in the training data set is highly imbalanced. So I've used smart oversampling to uh, in, to balance the data set, as you can see in this chart compared to this chart. So let's come on to the ML model implementation, which is the fun part. So I've done three types of regression, which is random forest regression, gradient boosting regression, and XGBoost regression. So the goal is to train a model to predict IMDb score based on features like runtime, genres, release year, and cast of crew. So there is a mistake here and that I'm going to fix. Linear regression is not used, random forest and gradient boosting. I earlier used linear regression, that's why I didn't change that. So the first model that I've used is uh, random forest regressor regression. So the mean squared error and the mean absolute error were very low, and the R2 score was closer to 1. So mm, this indicates overfitting. However, this model seems to be a good contender for the best model as it has high accuracy. So after hypertuning, I've done hyperband optune hyper optimization with hyperband pruner. So hyperband optimization. So mm, even after this, I've used hyperband optimization because it has speed and efficiency, built-in early stopping, and works well with Optina, which is another library in the machine learning Python programming language. So the visualization is that the MSE and mean absolute error and the test mean squared error is still low. The mean absolute error has risen a bit, so there's a slight degradation in the R2 score as well, very slight, but this means that it has dealt with the overfitting. The second ML model is the gradient boost regression model. So it is not as well performing as well as the random forest regression model, which is the accuracy score is 0.78 or 78% accuracy or 79% accuracy, and the mean squared error and the mean absolute error are also uh, quite high, as we can see using this chart. But I've done hyperparameter tuning and cross validation using successive halving on a random search CV. So these are just some warnings which we'll ignore. Uh, After the successive halving, halv, halving, I'm having trouble to pronounce the word. Um, so the mean squared error reduced significantly, the mean absolute error also reduced significantly, and the R squared score increased significantly. So why I've used this successive halving technique is that it's an efficient parameter tuning method that systematically eliminates the least promising configuration in module rounds of training, multiple rounds of training. So I won't explain how it works, as it is written already there. You can look for yourself. So why are we using successive halving is because it is randomized faster than the randomized search CV. It was taking a lot of time, more than 1.5 hours to run the randomized search CV. So that's why I used successive halving. More efficient than grid search, balances exploration and exploitation, scales well with large data sets. Since it is a large data set, that's why we used successive halving, and the results are very promising. So it worked well, as we can have already explained, improved the accuracy of the model, and The mean squared error indicates how far predictions deviate from actual values. Lower values mean more reliable prediction. High MSE could lead to poor decision making reading based recommendations. Mean absolute error shows the average magnitude of errors. Lower MAE means the model predicts closer to actual values, crucial for content rating accuracy. The R squared score or the R2 score measures how well the model explains variance. A higher R squared score indicates the model effectively captures patterns supporting business decision based on user rating. Means the accuracy of the uh, R squared score, accuracy of the model is good. So the third model is the XGBoost regression model I've used. So this model performs very well, not as good as the random forest regression model, but rather random forest regression model indicates overfitting, which this does not because the ME and MSE are moderately high, while the R2 score is also very high. So I've done an optimization on the uh, XGB regressor model. So these are just some warnings that we're going to ignore because it's related to the Python version. So the mean squared error is lower now. The mean absolute error is also significantly lower now, and the R squared score has gone up to the value of 0.994874, 0.9974. So this is the best performing model without overfitting. So I've used the XGBoost regression regressor as my final prediction model because it performs with the best accuracy with lesser chance of overfitting as compared to the random forest regressor. Also, it has very low mean absolute error and mean squared error, meaning the model is performing with very less error in predicting IMDb scores. So I'm not going to explain how the XGBoost model works, but the great advantages are that it uses gradient boosting. Using boosting, they need to iteratively iteratively improve weak learners. Regularization environment 2 prevents overfitting. Handling missing data automatically manages missing values. Parallelization and speed optimization optimize for performance with GPU support. So now I've done a shapely additive explanation analysis. So this returns the value that uh, engagement scores and IMDb votes and TNDB score are the most uh, important features, as you can see using this chart. I'm not decided to make it into a wiggle file. In conclusion, these are the business impacts I found. Business impacts are since studios can leverage predictions to estimate audience reception before release, producers can adjust budgets and cast sizes to maximize IMDb scores. Streaming platforms can prioritize acquiring high-rated movies based on feature importance and access. So, in conclusion, what I've seen is that IMDb scores are the most important metrics that we see while deciding what to watch on an Amazon Prime Video, and uh, that's why I chose IMDb score as my target variable to train models based on that. And in the EDA, we explored many different business impacts and many different factors that can be used in to influence the business impact of the Amazon Prime. So this is the conclusion that I have um, made from this project. Thank you.